Welcome students. Hi, hello, welcome to all. Today we are going to discuss about the parallelogram law of vectors. This is the second method in addition of vectors, whereas head-tail method will be failed when the angle between two vectors is not 90 degrees. If the angle between two vectors is not 90 degrees, then we have to choose the method that is parallelogram law of vectors. Here the angle between two vectors will be theta. What is the process? What is the derivation of parallelogram law of vectors? Now, firstly, we will see how we are going to do this method. Here it is given that join two vectors from tail to tail. You have to join two vectors from tail to tail as two adjacent sides of parallelogram. They should be seen or observed as that the two vectors are the adjacent sides of parallelogram. After that, complete imaginary parallelogram. The imaginary parallelogram will be drawn. Here, in this parallelogram law of vectors, the magnitude will be r is equal to root over a square plus b square plus 2ab cos theta. By calculating this value, by placing the values of magnitudes of the two vectors, we will get the value of magnitude of resultant. The resultant will be the diagonal of two vectors which are formed as the adjacent sides of parallelogram. The diagonal of a parallelogram that has been drawn will be the resultant of the two vectors, and the resultant vector is also a vector. It is not a scalar. It also have a direction. So it will definitely have a direction. How can we find the direction of the resultant? The resultant direction can be known by calculating this value, that is tan alpha is equal to b sin theta by a plus b cos theta. This will be the process that we are going to do in parallelogram law of vectors. Now, here we are going to derive how this equation has come and how this equation has come. We are going to derive this equation. Now, here is the derivation of parallelogram law. Now, we have the two vectors a and b. These are joined tail to tail, and the imaginary part of the parallelogram has been completed by dotted lines. By joining the tail to tail of two vectors, these are seen like an adjacent sides of the parallelogram. Now, the diagonal of this parallelogram is the resultant of the two vectors. This is also a resultant. That means this is also a vector. The resultant is also a vector. That means the resultant has both magnitude and as well as a direction. Now, we are extending the vector's length, p vector length up to q, and the point from point O to q. Here, by extending it, here we can see that a triangle is formed here. This is a right angle triangle, and the another triangle is also another triangle is also there, that is MQO. Here we have two triangles, that is PQO and MQO. These are the two triangles formed by extending the point P and a point O. Now, first we are going to observe triangle OPQ. Triangle OPQ. From this triangle, we are going to find out an equation. When we observe the triangle, when we see the triangle, here there is an angle theta. Here it is the theta, and this angle is repeated here. Here the angle between A and B is repeated at point P. By observing this triangle OPQ, here sin theta is equal to, that means sin theta, the sine of the angle theta is equal to opposite side by hypotenuse. opposite side by hypotenuse. Opposite side is OQ and hypotenuse is PO. Sin theta is equal to OQ by PO. Sin theta is equal to OQ. The value of PO is equal to value of MN. Why? Because the lengths of the opposite sides of a parallelogram will be equal. This length and this length is equal, so that the length of MN is B, so that the PO length is also B. Here sin theta is equal to OQ by B. OQ is equal to B sin theta. This is the first equation we get from this triangle. Afterwards, if we observe, here is the theta. Now we are going to find out what is cos theta. Cos theta means adjacent side by hypotenuse. Adjacent side is PQ, hypotenuse is PO. PQ by PO. We know the length of PO is B. Cos theta is equal to PQ by B. By sending this B to opposite side or another side, PQ value will be B cos theta. That is the equation 2. We got the value of OQ and we got the value of PQ. Why we are finding these two values? Why? Because from the triangle MOQ, we can find the angle between MO and MQ. If the angle between MO and MQ is found out, then we can find the direction of the resultant vector. The direction of the resultant vector can be found by the angle between resultant and MQ. That is angle alpha. To find angle alpha, we want these two sides length. Of course, we can find the angle between resultant and MQ by knowing the value of MO and a value of QO. By that two sides also we can find the angle alpha, and also we can find the angle alpha by knowing MO and MQ. But if he doesn't know the resultant magnitude is not calculated. Before the calculation of resultant, we can find out the angle between the resultant and MQ by this process. Now, from triangle MOQ, we can find the alpha angle. By finding the alpha angle, we can find the direction of resultant vector. Now, observe here, tan alpha is equal to OQ by MQ. OQ by MQ. OQ by MQ. That means tan means opposite side by adjacent side. Here OQ is the opposite side and MQ is the adjacent side. You can observe that MQ is the sum of two lengths. You can observe that MP plus PQ. That here we can write in the second step, tan alpha is equal to OQ by MP plus PQ. The length of MP is A and the length of PQ is B cos theta and the length of OQ is B sin theta. That we are going to substitute here. Tan alpha is equal to B sin theta by A plus B cos theta. This is the final output of tan alpha. By finding this value of B sin theta by A plus B cos theta, by calculating this value, by substituting the numbers that are given to these variables, by substituting them, we can find the value of tan alpha. That will be one number. By sending this tan to other side, we can find the angle alpha. After knowing the angle alpha, we can automatically decide, we can automatically know the direction of the resultant vector. This is the derivation of direction of resultant vector. Now we are going through derivation of magnitude of resultant. Magnitude of resultant, already we know the formula R is equal to root over A square plus B square plus 2AB cos theta. Here is the derivation of it. Now, by observing MOQ triangle, now we are going to deal with the triangle MOQ. It is a right angle triangle. The angle between the MQ and MO is alpha. By observing it, there are three sides of a triangle, that is hypotenuse and adjacent side, and it is opposite side. Hypotenuse is MO, adjacent side is MQ, and opposite side is OQ. Now you observe this. As usually we know the formula, hypotenuse square is equal to opposite side square plus adjacent side square. Opposite side square plus adjacent side square. It is Pythagoras theorem. As usually, this theorem will be taught in, I think, in your 10th class. By observing this, r square, hypotenuse value is r, that r square is equal to OQ square plus MQ square. R square is equal to OQ square plus MQ square. R square is equal to, what is the value of OQ? It is B sine theta. Already we have derived it. The first equation that derived by us is that only. B sine theta is the value of OQ. OQ square means B sine theta whole square, plus MQ means it is the sum of two lengths, that is MP plus PQ whole square. Here B sine theta whole square means B square sine square theta, and MP value is A and PQ value is B cos theta. By expanding this, we can observe that it is like A plus B whole square. By expanding that, we can get A square plus B square cos square theta plus 2AB cos theta. Here it is B square sin square theta, it is B square cos square theta. By taking common B square, we can find that R square is equal to B square of sin square theta plus cos square theta, plus there is A square here and there is plus 2AB cos theta here. Sin square theta plus cos square theta, as all we know, it is the value 1. So there is A square plus B square plus 2AB cos theta, that is the value of R square. By sending square to another side, we can get the root of this total value, that is R is equal to root over A square plus B square plus 2AB cos theta, that is the value of magnitude of resultant, that is R. Now we came to end of this class. In this class we have learned about the derivation of the magnitude of resultant and the direction of resultant of two vectors when the angle between them is less than 90 or more than 90 by the parallelogram law. So I think this is helpful for you. This video is helpful for you for learning about parallelogram law derivation. In the next class, we are going to learn about some problems, some difficult problems, some types of problems on parallelogram law. Thank you for watching this video. Stay tuned, watch more other videos about this vectors class, and in coming days we are going to produce so many number of classes on physics and chemistry and as well as mathematics. Thank you for watching this video.